Hello, my fabulous chemistry griffins. Unit vocab for atomic theory. Ooh, let's see if I can keep this one short because guess what we added? Pictures. An anion. Check it out. If I have a regular atom and I add an electron, I make an anion. So there's a little picture talking about what I'm saying. And now the verbs. Whoops. An anion is an ion with a negative charge because it has gained an electron. That is going to be one of the biggest hang-ups for Regents chemistry for the entire year because, mister, I added something and it got negative. That's really a kicker. But the reason it is because I'm adding something that is negative. An electron has a negative charge, so I like to think of it as adding debt. I'm just going to say it now. My bank account goes down when I take out college loans. You're going to hear me say that 100 times. I'm going to say it now and get it off my chest. Whew, I remember. We're going to get this straightened out. I'm going to draw it for you. You'll understand when I draw it. An atom itself. Here's a cool picture. I got the inside nucleus. Electrons are on the outside. An atom is the smallest unit of an element that maintains the properties of that element. Okay, so it's the smallest building block of a particular kind of element. The atomic mass. In this picture, you notice I add up protons and neutrons to get my total mass. If my carbon atom has 6 protons and 6 neutrons, add those bad boys up. We will find out that protons and neutrons are the ones that have mass. With a total mass of 12, the atomic mass is the overall mass of an atom, expressed in atomic mass units, and I put in parentheses protons plus neutrons. That is how we derive it. The atomic number. The atomic number is equal to the number of protons. So how many protons are in a particular atom is its atomic number. We will find that that is the unique identifier for every atom. So simply the number of protons in the nucleus. It's the same for all atoms of that particular element like carbon, but carbon's the only one that has 6. Nitrogen's the only one that has 5. We base what element we are based simply on our number of protons. Cation is the removal of an electron, so it is a positive ion. I lose an electron, I become more positive. You can actually kind of see it in this picture. Let me just take a second. Right? If I have a positive in the middle and I have a negative on the outside, they kind of cancel each other out. But then when I go and lose this electron, the electron goes away, all that's left is that plus in the middle. That's how, when I lose, I get positive. Losing electrons is a positive thing. So a cation is an ion with a positive charge because it done gone and lost an electron. Don't know where that electron went. Somebody else scooped him up. The ionic charge. This is the overall charge on an ion. So you'll see I have to relate the protons and electrons. So if I have 9 protons and 9 electrons, my net charge or ionic charge is 0. And another example of an anion that we just talked about, 9 protons, 10 electrons. Electrons are more than protons, so when I subtract those two numbers, I get a -1. That's my charge. My net charge is my ionic charge, the charge on the whole thing, protons and electrons. Okay, the overall charge on the ion based on my total number of protons and my total number of electrons. It will be easy math, but it will be math nonetheless. An electron on the outside there, negative charge subatomic particle on the outside. Subatomic particle with a negative charge, he's got no mass, and he resides in the orbitals, which are outside the nucleus, is what that picture was meant to show us. Okay. Electron configuration. Oh, go back. This is an example of some electron configurations. This shows me that I have 2 electrons in the first shell, 8 electrons in the second shell, 8 electrons in the third shell, and 2 electrons in the fourth shell. It is a numerical description of how many electrons I have and where they are. Okay, so an electron configuration shows me the arrangement of electrons in an atom. In that picture you saw, it's numeric. We're going to keep track of how many. An element is Oh, check it. There's the poster in the back, or the puzzle in the back of our room, right? Elements. An element is a unique kind of matter. It cannot be broken down by chemical change or further anymore. For our case and purposes, we're not breaking an atom apart into all the quarks and subatomic particles. We will see what they are, but as far as we are concerned for this unit, or for this whole course, we are not breaking them up too much. It's not man-made style. Excited state versus ground state, which is next. The excited state is when the electron that was here went up there. It got excited. Kind of like that 3-year-old all hopped up on sugar. We know what that looks like. They go a little bit crazy. Okay, so he jumps up a level because he's got energy. Okay, when an electron has gained enough energy to jump up an energy level, we will find they can jump up 2 or 3. The ground state is where he was to begin with. Normal, low, stable energy. He's the ground state. So ground state is how we're going to find normal atoms. So the lowest energy state of electrons around the nucleus. Lowest energy state means stable, by the way. Little foreshadowing there. An ion. An ion is any atom that has gained or lost an electron. So we'll see in this particular picture, I have one valence electron out here in sodium atom. This little symbol tells me I am an ion, and notice he is not there anymore. Where did he go? He is gone. I lost that electron. That's how I became a positive ion. And you know what? Since I'm here, let's even, no, we're not going to, I don't have my number of protons. I'm not going to show you graphically how we calculate that anymore, but that is what an ion is. I gained or lost an electron. I can do both. We can play games, and that will change our charge. So an atom or molecule that has gained or lost one or more electrons, it will have a positive or negative charge as a result, because our number of protons and electrons will no longer equal. Isotope is our other I word we need to use, or need to learn. Isotope, in this, as you can see in this picture, hydrogen 1, hydrogen 2, hydrogen 3. If it's hydrogen, they all have 1 proton. In the picture, we see that there's different numbers of neutrons, which gives us different masses. So, an isotope is the same element with a different mass, which means it has, different number of neutrons, because I can't change the number of protons. So if I add neutrons in, I will get a different mass. A Bohr model. This is a map of the atom. Shows me the number of protons, the number of neutrons in the nucleus, the number of energy levels around the nucleus, or the orbitals, or energy levels. That word is synonymous. That is each ring. And then the dots represent the electrons that are in each orbital. This Bohr diagram gives me so much information about every atom, sometimes more than we need. But by definition, it's a diagram that shows the nucleus with all the energy levels and electrons. That'd be the Bohr model. Neutrons. Neutrons are the neutral subatomic particle in the nucleus, kind of the glue that holds the nucleus together. All those positive protons keeps them from repelling. So neutron, subatomic particle with no charge, because it's neutral. We find them in the nucleus. Neutrons are in the nucleus. Neutrons are neutral. Okay, those are things, kind of sayings that will help us remember it, but we do need to use those factoids to do some of the calculations as far as charge and mass. Nuclear charge. Nuclear charge is the charge of the nucleus. Looking into the nucleus, I have protons and I have neutrons. We will find out that only protons have charge. So the nuclear charge is synonymous with the number of protons in an atom. The charge of the nucleus only. This differentiates between that ionic charge we did earlier, guys. Just because the word charge is in there, I don't want you to get those mixed up. Nuclear charge really means just the nucleus. The ionic charge is the whole thing. So it's a big difference there. I want to talk about it here while we're doing vocab, and you'll hear me talk about it more coming up. An orbital. Here is a picture 3-dimensionally of what orbitals look like. This is some high-end calculus stuff that we are not going to get into. There are geometric shapes of atoms that we don't have to do anymore. Yes, thank you, New York State. But you need to know that orbitals exist. What an orbital is the region of the atom where the highest probability of finding an electron is. That is muy importante, that statement. So now we know what an orbital is. Proton. Proton is king. Protons are in the nucleus. They have charge and they have mass. They are king. They got both things. We will find out. So a subatomic particle with charge in the nucleus, it also determines the atomic number. So it's really important. We will find out we can't play games with numbers of protons. We got them and that's it, and that's where they stay because they are king. Valence electrons. This is a specific kind of electron that by definition is in the outermost ring. So I'll start here with chlorine. These electrons here in the outside, oops, wait, sorry, because smartboard's off just a smidgen. Down here, there we go. These outer ring electrons in iodine, it'd be these, whoop, silly smartboard. Down here, see the outermost ring? These guys are specific. These guys are the valence electrons. These are the most important electrons to us. They will give me chemical character, tell me how these things are going to behave, how they're going to bond, how they're going to react. These are where all the changes happen with when atoms get next to each other. So they are the electrons in the outermost energy level. They do determine the chemical properties. And if you're listening, might be a multiple choice question at some point. It's also the last number in the electron configuration. Lewis dot diagram is the other picture we need to see, and I didn't have a picture come up for Lewis dots. Why is that? I didn't, bummer. Lewis dots didn't show up. Sorry about that. Diagram of atoms showing their symbol and their valence electrons. So let me do nitrogen real quick for you. There's my symbol for nitrogen is an N. Nitrogen has 5 valence electrons, so I'm going to put 5 dots around it. You're going to hear me say this a lot. First 2 together, 1 at a time around the bus. Sorry, the bottom one came out a little funny because, again, I got to fix the smartboard, but I will do that for the next video. There we go. There's nitrogen with these valence electrons, 5 of them. First 2 together, 1 at a time around the bus. Nitrogen. That is a Lewis dot diagram. We will learn how to draw them for every element that we can. There's how many elements on this periodic table? 114. We can draw it 114 times. We won't need to, but we can draw it for anyone when we are done with this. So there's your vocab. I will see you guys in class tomorrow, and you can take your vocab quiz now as soon as you are ready.